Okay, everybody. So yesterday we talked about wire feed welding theory. Today I wanted to go in deeper in depth into the actual nuts and bolts, the parts of the machine. Because one thing about wire feed welding is the machine is a lot more complicated and there's a lot more options with the machine. And there's also things that can go wrong, and I want you to be ready for those. And that'll be coming in a later video, how to fix the things that go wrong. But I want to talk about the wire first. So yesterday we talked about the differences between flux core and MIG welding. And so those would be two different types of wires. Now the wire that we're using is MIG welding wire. But more than that, the wire itself comes in different sizes. And so for our machine, this machine right here is a smaller machine. It plugs into the wall. It's only a 110 volt machine. That means it's only capable of producing so many amps to weld with. So we're not able to have a really deep penetration, welding material this thick with that machine probably isn't going to go real well. We can produce a good weld on it, visibly speaking, but is it going to have a lot of strength? No, we're not going to be able to penetrate and melt deep enough into the metal to get a lot of strength. But it can do just fine on material like this. The diameter of the wire, when I talk about the diameter of the wire, I'm talking about the actual, how far across the little wire is in here. The wire that's in this machine, and Dina, this is what I'd ask you to zoom in here, is 0.023 in diameter. Okay, now that's kind of a smaller wire, and that's going to work well with this machine because we're going to be able to produce a steadier arc and just a nicer puddle with that 0.023 wire. Now, just to show you as an example, like the welders that we have in the shop, the bigger ones, those are going to use a 0.035 diameter wire. And so we have a wire that's 50% bigger than what's on here. Basically, we have machines that can produce a lot more electricity. They're far better at welding a thicker steel. So we want to be able to put out just a higher quantity of wire. Remember, our wire is used to create our bead, but it's also used as a filler. To act as a filler and also to fuse the metals, the two pieces of metal together. And so the wire size that you use when you're welding makes a big difference for the quality of your weld depending on what you're welding as far as material size and the machine that you have to work with. Okay. When we leave the spool here, we have some more stuff here. So here we have our drive rollers that actually drive our wires. So if I lift this thing up right here, you can see that our wire is basically just fed from our spool across our drive roller, and then this little bearing pushes down on it, and then that's going to go right into the liner that goes directly into our welding gun. You can see there's the one end of our liner here, here's the other end of our liner right here. Okay. Then we have our electrical connections. Now once again, what do we have here? We have our positive and negative. We need a circuit. So this one I think it's this one right here, this is going to this big block. And that big block is connected directly to our welding gun again. That's connected to our brass piece right here, which connects to our diffuser. It's supposed to go faster than this. Connects to our diffuser, which connects to our contact tip, which connects to our wire to give us the electricity that we need in our wire to produce the arc. The other lead right here is going to go directly to our ground clamp. So that's here we have our electrical connections, we have our connection between our motor here, and we also have our drive wheel. Okay. We get down to the end here, where our diffuser is and our contact is. Once again, on our contact, I don't know if you can get in close enough for this, Dean. It's going to be really hard to see. Maybe if I put it on the table. Okay. If you look at our contact, you can see a size written, embossed into the contact. And our contact there is size 0.023. our contact size has to match the wire size. For two reasons. Basically, obviously, if the contact size is smaller than the wire size, the wire is not going to be able to get out of the hole in the end, and that's not going to work at all. But if our hole in the end is too big, then what that allows is it allows splatter and stuff to get inside the hole and plug it so the wire doesn't come out again. And no doubt, things like that do happen even with the correct tip size from time to time. Okay, so it's important when you're swapping out tips that you make really sure that you have the correct tip size in your machine. Okay. The last part for us is our shielding gas. So I'm going to go over the shielding gas regulator here in a different video. But here we have our shielding gas, our regulator, and our hose going up to the machine. Inside of the machine, when I pull the trigger, there's an electric valve that opens and releases the gas. And then our gas is going to come out. Dina, can you get in here again, please? Through this hose right here. I don't know if you can see that hose, everybody, but that hose goes once again right to our this big block here, and it's fed through the same hole that our liner is. And so our hose our gas surrounds our liner, so that when we put our diffuser on, the gas goes through our diffuser and comes out around the welding wire on the other side of the contact tip, and it's held in place, and the gas is directed by our nozzle. Okay. This brings me to one more thing that I think it's important to talk about when we're talking about wire feed welding, and when we're talking about MIG welding with gas. One nice thing about stick welding is the cloud is not affected. The cloud of shielding gas is not that affected by wind. Okay, so you can weld outside and that cloud will hang in there pretty well. Same thing with flux core welding. The cloud hangs in there pretty well. Well, with MIG welding, that cloud doesn't hang in there quite as well because it's just forced. It's basically forced air around the weld. And so if we have a little bit of breeze, which we always do in the Red River Valley, that cloud of air is going to be pushed off to the side. That makes welding outside with MIG not a really efficient process. It's hard to do it and do it well. And so usually when you see people welding outside, they're usually either welding with our old-fashioned stick welding, or they're welding with a flux core welder. A lot of bridge work and a lot of metal buildings, they're basically using a wire feed welder, but they're using flux core. When you go inside of a factory or inside of someone's shop or at home, that's where it's really easy to work with inert gas, because then we don't have the air movement that we do if we were outside. So in our shop, I don't have any flux core welding. Everything that I have is inert gas. Or if you go over to Articat or something inside their factory, everything they're welding, it's going to be CO2 argon, just like what we're using. So there's definite advantages to MIG welding, but there are some drawbacks like that. Okay. All right, that covers it for this video, everybody. We'll see you on the next one.